Alright, let's get started. So in this video, we're going to go through some examples using our four new trig functions, specifically tangent, cotangent, cosecant, and secant. So in order to identify the values of these functions for our special angles, we could use a unit circle. So these new functions are related to sine and cosine, and so we could use the unit circle, which tells us the sine and cosine values, to determine these new functions. But I think it's important first to see how it's done with the triangles. So we're going to work on this with the reference triangles and reference angles first, and then at the end of each example, I will relate it back to the unit circle, just to give you an idea of what that looks like too. So our basic steps for when we're trying to find trig function values for our special angles are the following. This is the same for sine and cosine too. So our first step is to identify the reference angle for the angle we were given. Then what we want to do is to be able to draw the reference triangle that's related to the reference angle in the correct quadrant so that we have the side lengths with the correct sides, whether they're negative or positive, and we know which triangle to refer to. Then once we have our reference triangle drawn, we can find the corresponding ratio of sides that's associated to the trig function. So all 6 trig functions are a ratio of sides of the triangle, and so we just need to know which ratio we're looking for. Alright, let's try a first example. So let's identify all 6 trig function values for the angle theta equals pi over 3. So if you'd like, you could pause and try this on your own. I am going to go ahead and just do it right away since this is our first example we're seeing like this. So for my first step, identify the reference angle. Pi over 3, which is 60 degrees, is in the first quadrant, and so it actually just is its own reference angle. So pi over 3 is the reference angle, and we'll just draw the pi over 3 triangle in quadrant 1. So quadrant 1 means both the x and the y are positive, and so our triangle looks like this, and the side lengths are all positive. So we have x, y, and r. I'm going to label that just to help us out when we start doing the trig functions. So we're trying to find all 6 values, but let's start with sine, cosine, and tangent, and I will just wait to do the other 3. So I'm going to refer back to what the definitions are first. So for sine, we have y over r, cosine, we have x over r, and tangent, we have y over x. So now we're in this step 3 where we really just need to identify the proper ratio of sides. So sine is y over r, that's square root of 3 over 2, over 1, which anytime we divide by 1, it stays the same, so it's square root of 3 over 2. Then similarly for cosine, we have x over r, so adjacent over hypotenuse, which is 1/2 over 1. Again, when we divide by 1, it stays the same, so we have 1/2. Just as a reminder, the reason that works is because if we have something and we divide it into one piece, we just get the same thing back. So if you were eating a cake and you said, I'm going to cut this cake into one piece, that would be the whole cake. You'd be eating a whole cake. So when we take these values and we divide them by 1, we just get the value back. Then for our new trig function, our first one, we have tangent. So tangent is y over x, or opposite over adjacent. So I'm going to have square root 3 over 2 all over 1/2. Then to simplify this, since we want it to look a little cleaner, I'm going to take the denominator of 1/2 and multiply it up, so multiply by the reciprocal of it. So I'm simplifying this as square root of 3 over 2 times 2 over 1. So that 1/2 comes up as multiplying, and we multiply by the reciprocal specifically. Then our 2's are going to cancel, and so I'm getting square root of 3 over 1, which is just square root of 3. And that's our tangent value. So I want to highlight something here. The way we did this involved a lot of dividing by 1s or having these complicated fractions with the tangents, and so I want to show you an alternative to the reference triangle that you might find easier. This is completely up to personal preference, you get to choose, so I just want to give you this so that you have options. So because we're looking at ratios of sides, we can just look at similar triangles because they preserve the ratios. So I'm going to take this same triangle, but just multiply all the side lengths by 2. So instead of a hypotenuse of 1, I'm going to have a hypotenuse of 2, and then the other side lengths will get rid of that denominator with 2, since we're going to multiply by 2. So my new side lengths are square root of 3 and 1, and 2 for the hypotenuse. So let me show you that this gives us the same answers. So for sine, we would do opposite over hypotenuse. That's square root of 3 over 2. That one gets us the same answer. Then for cosine, we would do adjacent over hypotenuse. So that's 1 over 2. That would also give us the same answer. And for tangent, we would do opposite over adjacent. So we would do square root of 3 over 1, which is just square root of 3. So truthfully, I kind of like this triangle. I think it sometimes makes it easier. But the reason I teach the other triangle first, the one with the radius of 1, is because it connects to the unit circle by having the radius of 1. So the unit circle specifically has a radius of 1, so I like that the triangle does too. However, you could use the similar triangle, the one with the hypotenuse of 2, if you'd like. It works just the same. So I will show both of them for the rest of the example. Alright, so what we have left is to find the other 3 trig functions. So we have cosecant, secant, and cotangent. Cosecant is r over y, secant is r over x, and cotangent is x over y. So let's just go ahead. So for cosecant, we have r over y, or hypotenuse over opposite. So on my initial triangle, the first one I have, that's 1 over square root of 3 over 2. So when we divide by this complicated fraction, we're actually multiplying by the reciprocal. So I have 1 times 2 over square root 3, which just gives me 2 over square root 3. Now, you really now might like this other triangle better, because if you look, we just do r over y, which is 2 over square root 3. And now we don't need to worry so much about having all these complex fractions. Personally, I like fractions, I don't really mind, and I want to show them to you so that it's some good practice. However, you get to choose, so you pick the triangle that works best, and I will show both. Okay, so for secant, now we have r over x, so that's 1 over 1/2 on my initial triangle. When I divide by 1/2, it's the same as multiplying by 2 over 1. So I have 1 times 2 over 1, which is just 2. So my secant value is 2. With our new triangle, that would be r, which is 2, over x, which is 1. So 2 over 1 is 2, we get the same thing. All right, lastly we have cotangent. So cotangent is x over y, so I take x 1/2 divided by y, square root of 3 over 2. When I divide by that fraction, I can multiply it by the reciprocal, so I have 1/2 times 2 over root 3. My 2's cancel, and I'm left with 1 over root 3. We can do the same thing on our other triangle. We just do x, which is 1, over y, which is root 3, and we get to bypass that step with the fractions. And there we go. So we found all 6 trig function values, and we did them all using the triangles. So something that's really cool about these trig functions is there's lots of patterns in them, and it means that there are multiple ways to solve the problems because the patterns are so strong. So if we take sine, which is root 3 over 2, and we take its reciprocal, we're getting the answer for cosecant. We're getting 2 over root 3. So potentially, once you found sine, you kind of already know cosecant because you can just find the reciprocal of the fraction. So you don't even really need to look at the triangle if you don't want to. Similarly for cosine, we have 1/2, and secant is the reciprocal, 2 over 1, which is just 2. Then for tangent, we have square root of 3. That's like doing square root of 3 over 1, since we can always have that divided by 1. And so when we take the reciprocal for cotangent, I'm getting 1 over square root 3. So you can see how these all have this relationship where you go from one to the other by taking the reciprocal and vice versa. So once you've found either sine, cosine, or tangent, you basically already have cosecant, secant, or cotangent, if you want. I kind of like having multiple ways to get the same answer. For me, it helps me feel really confident in the math I'm doing, so I often kind of do all of these. Like as a final check at the end, I will just look and make sure that they're related in the way that I thought they should be. But just know that you have lots of options for how you want to get your final answers. Also, just one more comment. Some teachers are really picky about having radicals, the square root symbol, in the denominator, the bottom of fractions. So personally, I don't really care, I don't really think it matters, and I kind of like leaving them there because it reinforces the pattern. So don't worry about needing the answers to look a certain way. We just want to make sure that we're getting the value. So I don't really care what it looks like as long as it's exact, it involves our side lengths, and we can see the patterns. Okay, so we've found all the values for pi over 3 by using the reference triangle, but you can also look at the unit circle if you'd like. I tried to emphasize the reference triangle because we're not always going to be using angles that are on the unit circle, so it's good to know how to use the triangles. But if you have a unit circle and that's what you'd like to use, you can see that we have the cosine and the sine values from the unit circle. So the cosine is the x, 1/2, and the sine is the y, square root of 3 over 2. Then for our new trig functions, if we wanted to do tangent, we would do the y over x. So that would be square root of 3 over 2 over 1/2. And then we have the same calculation that we already did in the problem, but that will get us square root of 3 as our tangent value. Then for the other trig functions, I suggest just finding the reciprocal of the fractions that we already have. So cosine is 1/2, which means secant is 2 over 1, or 2. I'm just taking that fraction and finding the reciprocal. Then because sine is root 3 over 2, I could take the reciprocal, which is cosecant, 2 over root 3. Then for cotangent, you could do x over y, since that's what cotangent is. So we'd have 1/2 over square root of 3 over 2, which when we do the same math as we already did, we'd get 1 over square root of 3. So you can also use a unit circle for this, but it really is the same process as using the reference triangles, so I recommend doing that. And the reference triangles are going to be really useful, or at least being able to read a triangle using these trig functions is a super useful skill that we're going to need to be able to do. Okay, so I'm going to leave this video to one example just to help split it up, and I'll provide a second video that has the second example in it. Thanks so much for watching, and I will talk to you in the next one.